Here, as you can see on the desktop, we have no file example.txt. So by running the code, it will create the example.txt on the desktop, and then record all the data that it gets into that file here. As you can see now, we have the example.txt, and because the S appears here because the speed of the computer is a little bit slower than the data stream, so the program the system alarms to stop that we have some data escaped by the computer. I will stop the process and look at the volume of the file. As you can see here, it's very large. It's about 1.1 gigabyte. Thank you. Now we move to the fourth part by Lan Chao.
Yeah. Okay. Now I will introduce the GRC of the JU Radio 2. GRC is a graphical coding style of the radio, and you can enter GRC by open the terminal and just type GRC. After a minute, you can see the blocks of the GRC. That's a graphical coding style. Instead of coding your C++ block and the Python block and the Python block line by line. So GNU Graphical Radio Companion is a graphical tool that creates signal flow graphs and generate flow graph source code. And this one is quite easy. The first step is that adding purple blocks to the diagram and setting the parameters. The second step is connect purple blocks with each other and saving the file. Then the computer will generate a GRC file, and you can also convert it to a Python file. The third step is that executing the flow graph and receive the signal by using USRP2 receiver we designed before. And here are some simple examples. The first one is that we can view the signal in the time domain and spectrum domain. As we did in previous process, we coding it line by line use Python file, and now we can do it in a graphical way. And here is the first example. You can execute it, and then it will generate a GRC file, and you can run it by click this button. And you can see the frequency domain and the time domain. The signal transmitted was decomposed into in I channel and Q channel. So there are two sinusoidal waves here, and one is the spectrum. And I will show how to do it step by step. To do this, first you can choose the source. Here, the blocks are listed on the right side. Here are sources and sinks. and some other operators, time conversion and so on. First one, you can choose the sources. Here we choose this signal source will generate cosine wave for sine wave, and we can choose a throttle to stable the data. And then we can choose graphical sinks to view the signal in time domain and the spectrum domain. Here is the FFT sink, and here is the scope sink. Since the general radio requires that the output of a block and the input of the block must be matched, so we can see the output type here. The blue means the float. Oh, complex. Sorry, the blue means the output type is complex, and if we change it, the color will change. So it's very convenient to view that. Here I changed the output, so the color changed. Different color cannot be connected, and if you connect it, it will be an error. It will be error. The color of the arrow will be red. That means the error here, and you must change it back. Then now the black arrow means everything is okay, and you can directly connect to the FFT sink and the scope sink. And then you can save it. Then you can run it.
Like signaling.
Yes, quite like signaling. And the second one is that you can view the constellation diagram of the signal using the GRC. Yeah, this one is a little complicated. I generate the random source here, and the random source will be modulated by the DPSK modulation, and then it will multiply by a constant, and then it will send to the USRP2 sink and transmit it. And here is the constellation sink block, and you can see the constellation diagram here. Since it's a DPSK modulation, so there's four points here. And if you change it to another type, like D8 PSK, there will be 8 points on the screen. Yeah, for this one, it's a little unstable, but there's still 8 points on it. And here, if you click on the block, you can connect it or disconnect it by clicking these two buttons. For example, if you pass it, then this one is disabled. And press this one is enabled. And then we can see the FFT diagram of this modulation. And also time domain and the spectrum domain. Yeah, here is the modulated signal in time domain, and the buffer is in spectrum domain. Then we will show some communication demos. I think we should stop.